All right, page 138, number 35. I can't remember what the direction. I think it said solve over the reals. I kind of lost my direction, but let's just solve it. And if we get some imaginary numbers, maybe we'll double check. But I think we're just going to get real solutions. We'll see. All right, so we need to solve this. There's two ways that I can see to solve it. We could work this fraction on the left and just, get a common denominator on the top and the bottom, multiply by the reciprocal, make it look nice. That's one way to do it. Or another way to do it is we could, cross multiply. It looks a little strange, but it's going to kind of handle that fraction right off the bat. If I take this times 1 and that equals this times this. And in fact, whenever I take this times this, I think it's going to make that fraction on the bottom go away. So that might be easier, maybe. I don't know. Doesn't matter. I'm going to cross multiply. So I get x plus 2 over x equals this times this is going to be, I'm just going to write it out so I don't skip too many steps and screw it up. All right, so expand. X plus 2 over x equals, that is 15x plus 20. Okay, just to get rid of the fractions, let's multiply both sides by x. Gives you x squared plus 2 equals 15. 15x squared plus 20x. And by the way, I should point out to you that right here I multiplied both sides by a variable expression, so x cannot equal 0. Or I should say I can introduce extraneous solutions. But whenever you cross multiply, you actually are multiplying by variable expression as well. I'm basically multiplying by 3 plus 4 over x over 3 plus 4 over x. And I do also want to point out that there's kind of a tricky domain restriction there. Like I can't really see what that domain restriction is. In order to know when that is equal to 0, you kind of gotta, when is 3x multiplied by x over x? When is 3x plus 4 over x equal to 0? When x is equal to negative 4/3. So that's a little tricky, right? So at the end, I think the things that I'm looking for are, my restrictions are this and this. So as long as my solutions aren't those two things, at the end I'm going to be okay. Usually you're okay, but never know. All right, so. All right, well, I I made a mistake when I worked it the first time. I don't know if you guys saw it. Like I said 20x, but I didn't put down a 20x. I lost this x right here. And so I got some imaginary numbers and I got all confused and the ones matching up for the book's answer. So I'm going to come back and add that x right there and do it the right way. 0 equals, subtract x squared, 14x squared, plus 20x minus 2. Divide everything by 2, 7x squared plus 10x minus 1. Factors of negative 7 that add up to 10. Not factorable. So now we got to decide whether we're going to use the quadratic formula or completing the square. I hate the quadratic formula, but I also don't want to divide by 7, and that doesn't look real nice either. Let's try the quadratic formula, I guess. X equals negative b plus or minus. I'm not going to do that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's plug our stuff in. B goes here, here, A goes here, here, and C goes here. Negative 10 plus or minus square root of 100 plus 28 over 14. X equals negative 10 plus or minus 128. It's got some 2's in it. Actually, it's got a whole bunch of 2's in it, I believe. So how many come out? 1, 2, 3 2's come out. So 3 2's come out as, well, I should say 6 2's come out as 3 2's. So that's 8 with 1 2 left over. To reduce that down, let's factor, I could factor a, well, whatever, just factor a 2 out. So x equals negative, come on. I'm sorry, this problem's killing me, guys. I'm sorry. You guys are probably saying, well, this is what it's like for us all the time when we do homework. I know. Math is hard. Keep working at it, though. Don't complain. Negative 5 plus or minus 4 square root of 2 over 7. And now I'm just going to check my answer in the back and just pray that it's right. Negative 5 plus or minus 4 root 2 over 7. Okay, I think we're good finally. Okay.